Moving on to the first question. Which of the following statements are true and which are false? Give reasons for your answers. Moving on to the solution for the first bit. The given statement is that only one line can pass through a single point. No, it is false because if we consider a point O, then there can pass a infinite number of lines through the given single point. Now, moving on to the solution for the second bit. The given statement is that there are infinite number of lines which pass through two distinct points. Now, it is also false because if we consider any 2 points, there exists only unique line which passes through the 2 points. Let the distinct points be AB. Then there may be number of lines passing through A and number of lines passing through B individually, but there exists only one line passing through A and B. Now moving on to solution for third bit. The given statement is that a terminated line can be produced indefinitely on both the sides. Now it is true because if we consider a terminating line that is passing through AB, then it can be indefinitely extended on the both sides and still it remains as line. So the given statement is true. Now moving on to the fourth question. He has given the two circles are equal, then the radii are equal. It is true because we know that radius is the line joining from center of the circle to any point of the circle. If the both circles are equal, then the distance from center to the any point on the circumference will be equal in the both the circles. So given statement is true. Moving on to the solution for the fifth one. The given statement is that in figure 5.9, if AB is equal to PQ and PQ is equal to XY, then AB is equal to XY. As it given that AB is equal to PQ and PQ is equal to XY, from Euclid's first axiom we can say that the quantities equal to same quantity or equal to one another. So here AB is equal to PQ and XY is also equal to PQ. So AB will be equal to XY. So the given statement is true. Now moving on to the second question. Give the definition for each of the following terms. Are there other terms that needed to be defined first? What are they and how might you define them? Now moving on to the solution. Let us consider the first bit. He asked the definition of parallel lines. The two lines are said to be parallel if they do not intersect when produced indefinitely. Example, let us draw two lines L and M such that if they are extended, they doesn't intersect at any point. So then these lines are known as parallel lines. Moving on to the second bit, he asks the definition of perpendicular lines. The two lines are said to be perpendicular if they intersect at right angles. Considering an example, let us assume two lines, that is line L and line M, such that angle between them is 90 degrees. Then L and M are said to be perpendicular lines. Now, in the third bit, he asks the definition of line segment. A terminated line or line of definite length is known as line segment. Let us consider an example. Let L be a line with two terminated points AB in the middle of definite length. Then AB is known as line segment. Now moving on to the fourth bit, he asks the definition of radius of circle. Radius of circle is nothing but the line segment joining center to any point on the circle. For example, if we consider a circle with center C, then any line segment joining center to the circumference of the circle or the point on the circle is called as radius. And in the fifth bit, he asked the definition of square. A square is a closed figure in which all the sides are equal and the angle between any two adjacent sides is 90 degrees. Example, let us consider a ABCD closed figure. It is said to be a square when AB is equal to BC is equal to CD is equal to DA and angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degrees. Now moving on to the fourth question. If point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half AB. Explain by drawing the figure. Now moving on to the solution. He has given the condition that there is a 2 points AB and he says that C lies in between A and B such that AC is equal to BC. So given condition is AC is equal to BC and he asks us to prove that AC is equal to half AB. We have Euclid's axiom that if a quantity is added to equals, then the final quantity also remains as equals. So here let us add AC on both sides, then we get AC plus AC is equal to BC plus AC. That implies 2 times AC is equal to, from the figure we can say BC plus AC is nothing but whole line AB, which implies now by transposing 2 onto right hand side we get AC is equal to half AB. This is what the required proof for us. Moving on to fifth question. In question number 4, point C is called midpoint of line segment AB. Prove that every line segment has one and only one midpoint. Now moving on to solution. From the above problem, we get the information that AB is a line segment in which C is the midpoint such that AC is equal to half AB. Now let us assume that there exists another midpoint D. Then we get AD is equal to half AB from the above concept. Now we know that things which are equal to same quantity or equal to one another, we can say as AC is equal to half AB and AD is equal to half AB, AC will be equal to AD. As AC is equal to AD, we can say that point C and D coincide. So finally we can say there exists only one point lying midway to both points. Moving on to sixth question. In figure 5.10, if AC is equal to BD, then prove that AB is equal to CD. Now moving on to solution. Let us note on the given condition that AC is equal to BD. From figure let us find out what is the value of AC and BD separately. Then we get AC is equal to, AC can be written as AB plus BC. Let it name it as equation number 1. And let us find the value of BD from the figure. On the figure, BD can be written as BC plus CD. Let us name it as equation number 2. Now, as AC is equal to BD, we can equate AB plus BC is equal to BC plus CD, which implies, let us transpose BC to right hand side, then we get AB is equal to BC plus CD minus BC. Here BC minus BC is nothing but 0. So finally we get AB is equal to CD. This is what the required proof for us.